your mouth out to blow. Don't know what a sliding rule is for. Well, I do know what it was too. What could be with you? What a wonderful world this would be.
Hey everybody, welcome back to Mr. K's 30 minutes of math. Good to see everybody. I hope you are enjoying your Thursday. It's a little bit sunnier outside today, so hopefully you got to get out and about and enjoy some of the weather. Well, let's get rolling. Oops, let me bring my screen back, and we're gonna start off with our riddle from yesterday. So let's dive right in, and let me take the video off so I can focus on what I'm doing here. All right, so yesterday's riddle, we had all these shapes that were standing in for numbers, and they represented two subtraction problems, and we had to figure out what number goes with each shape. So I'm curious, and I see we have a few folks on already. Did anyone figure out what the blue circle represented? The blue circle, anybody? Go ahead and write it in if you had an answer. I don't see anybody yet. Lots of hellos, which is wonderful. What about the orange triangle? Anybody figure that one out? Or the green octagon or the purple square? It looks like we don't have any answers yet, so are we ready to see the answer? Here we go. Here it is, my friends. So we could replace the green octagon with a 6, so let me do that. The orange triangle with a 2, and then the blue circle with a 1. And finally, the purple square with a 4. So that would be, all right, so 1 minus 1 is 0. That checks out. 2 minus 1 is 1. That checks out. And 6 minus 4 is 2, which also checks out. Very cool. All right, let's check the second one to see if that one worked out. All right, it would be 2, 1, 6. So 216. Minus 112 or 112. So that would give us 104. Does that work? Yep, that's supposed to be a 1, and that is supposed to be a 4. That was a hard one. I agree with you, Harper. Now, there are some ways to approach this. So let me give you a little bit of help to think about a problem like this. So first thing you might notice is that, look right, whoops, let me bring my marker back and use red. If you look right here, so triangle minus blue square equals blue square. So that is really interesting because what that tells us, for example, let's just pick a number. Let's say we didn't know what anything was, and we pick 5 for the orange triangle. And then we didn't know what the blue circle was. So let's just say we picked 1. 5 minus 1 is 4. The problem is, as you can see, these are the same and these aren't the same. All right, well, what if you tried, I don't know, we picked 3 and we picked 2 for the blue circle. Again, you're gonna find these are not the same. The only way to get these two blue circles to be the same number is if the orange triangle is what kind of number? Can anybody think about that? What kind of number does the orange triangle have to be if it's going to work? Can somebody type it in for me? Give you a second to think about what kind of number does it have to be? Let me give you a little Jeopardy for this one. Go. I tried to do my Jeopardy. Here we go. All right, I see a couple of folks have written in, and Henry, you're right, even, and I see Ezra wrote in even too. A few weren't sure, that's okay. So yeah, it has to be an even number. So let me erase all this stuff so we can do some more writing. So for example, if the triangle was 2 and the circle was 1, well, there it goes, it works. Or the triangle could be 4 and the circle could be 2, and there you go, it works. You get the same number. So that's one hint that we have about how to approach this problem. And we could kind of keep going down that path to figure out the rest of the pieces, but I know that was a hard one. I definitely admit that. So those of you who struggled with it, even if you didn't get it, that is totally cool. I'm glad that you struggled with it. All right, let's dive into our homework from last night. I know you all did it, right? And so let me just walk through this in case you did not, just to check in with everybody, see how we did. We're going to draw a number line. Remember, now we're using number lines to show our fractions. It says partition a number line from 0 to 1 in sixths. Okay, let's do that first. Let's put our number line down. Whoops, that's the wrong one. Okay, and we're going to do it in sixths. So we're going to start with 0 sixths, and at the end we should have 6 sixths, which is going to be 1 whole. In the middle, we should have 3 sixths. That should make sense because that's halfway there. And then 1 sixth, 2 sixths, 4 sixths, and 5 sixths. That's kind of hard to say. Okay, and then it says decompose 2 sixths into 4 equal lengths. All right, well, here's 2 sixths. So we now want to decompose that distance, so here, into 4 equal lengths. Well, right now we have 2 equal lengths, here and here. We want to break it up into 4 equal lengths, so I'm going to do that. All right, so now the question is, we've done that. Write a number sentence using multiplication to show what fraction represented on the number line is equivalent to 2 sixths. Okay, so 2 sixths. Now, we went from the fractional unit of sixths into something smaller, this fractional unit, and we broke it up by creating twice as many lengths, right? We went from 2 lengths, here and here, into 4 lengths, basically here, 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 and here. So we have twice as many, so we multiply both the numerator and the denominator, and we would have 4 sixteenths, that's not right, 4 twelfths, my apologies for that. And that should make sense because now we have twelfths. Here they are, here's 1 12th, 2 12ths, 3 12ths, 4 12ths. Voila. Okay, and then last, write a number sentence using division to show what fraction represented on the number line is equivalent to 2 sixths. So this would be going the other way. Whoops. 4 twelfths. And if we're going to go division from the smaller fractional unit, which is twelfths, to the larger fractional unit, which is sixths, we're going to divide by 2. And there you have it, 2 sixths. Same thing. All right, let us move on to our work for today. We're going to compare fractions using a number line. We're going to compare them, which is bigger, which is smaller, and things of that nature. So first thing we're going to do is to place these fractions on the number line. 1/3, 5 sixths, and 7 twelfths. 1/3, 5 sixths, and 7 twelfths. All right, my first question for you all, the 1/3, should it go in the red section or should it go in the blue section? Go ahead and type in your answer. Where should the 1/3 go? Which part of the number line? Red or blue? Red or blue? Where should it go? Do you need a little Jeopardy music? Let's check. I've got red, I've got blue, I've got red. All right, right, so it looks like we have lots of disagreement, and that makes me super excited because that means this is a great area where we should explore. All right, 1/3. Well, let's do this, my friends. Let's not forget everything that we've been working on. So I'm gonna use yellow now. And we're gonna do thirds. So let's label our number line. This would be 0/3. And how many thirds would 1 whole be? How many thirds would 1 whole be? Can somebody type in and let me know that? What's supposed to go right here? Thank you, Henry. 3/3. Okay. Let me get rid of the circle just so we're not too confused. All right. Well, let's pretend then we were whoops. Sorry about that. Let's pretend we just redrew the number line down here. If we want thirds, we need to split this up into 3 equal pieces. That's roughly equal. So we would have 1/3 here. And then we would have 1/3 here, which would take us to 2/3. And then we'd have another third there, which would take us to 3/3. So where is 1/3? It is right here, which is in the red section. So congrats if you had selected the red section, but no problem if you select the blue section. We are learning, and so all answers are welcome. All right, the next question though is what about 5/6? 5/6. Okay, go ahead, write in. Is it going to be in the red area or is it going to be in the blue area? 5/6. Ezra says blue. Let's see if anybody else has some thoughts. 5/6 is going to be red or blue. Unicorn Angel, love that name, also says blue. Well, those of you who are writing in and say blue, Harper says blue. Can you write in why? See if you can type in, I would love to see why is it going to be in the blue section. Aaron says red. Aaron, write in why you think it's going to be in red. I would love to hear your thoughts about this, so go ahead and type it in. If you have a reason for why it would be red or blue, I'll give you a little bit of time to go ahead and type that in. Not knowing is A-okay, not a problem, but go ahead and type it in if you have an answer for why it's red or blue. Okay, let's check it out. So Henry wrote in, it's more than half. So that means it's blue. I think that's what you were saying, Henry. I like that. Unicorn Angel, because you have 5 pieces out of 6. That's a great explanation. Ezra, it's blue because the numerator is at least, hold on, I need to move this, half of the denominator. Ah, very nice. Donna, I don't know, so I picked my favorite color. That is A-okay, thank you. Unicorn Angel, it's more than 50%. These are all some really, really great answers. So let me show a little explanation. If you remember right here, we have our number line with thirds. Well, you know what? We can go from thirds. We know how to do this now. We can go from thirds to sixths. Let's decompose from thirds into sixths. So I'm going to do it right now. So you'll see what that would give us then is 0/6, 1/6. I know it's hard to see. This would be 2/6, 3/6, 4/6, 5/6, and 6/6. So where is 5/6 fall? Well, right here. So those of you who said it was more than halfway, that's right, or 5 pieces out of 6, or 50, more than 50% of the way there, that's right. So you can see it's almost at 1. 5/6, 5 pieces out of 6 gets us almost to 1. We can also see how it is related to our first one, which was 1/3. All right, last one is 7/12. 7/12. So go ahead, type in blue or red area. Blue or red, where would 7/12 fall? Go ahead and give me your best estimate of 7/12. Where would it fall? Go ahead. All right, we have a blue. And we have another blue. And another blue, and another blue. Yes, you are correct, 7/12. And we could take our same number line and decompose the 6 into 12ths. All I have to do is break these in half again. Now we have a lot going on here, so I'm not gonna write it all out, but we could count for 7/12. So here we go. 1/12 would be right there. 2, 3, 4, 5, 6, and 7/12 would be right there. So you are correct, it would be in the blue section. Another way to think about this is 7/12. Well, how many 12ths do we need to go halfway? We need 6. And so if you have 7, you're a little bit more than halfway, which puts you into the blue section. All right, very good, my friends. Let us jump. I'm gonna come back to this. Jump to our math joke of the day. What do you call a number that can't stay in place? Go ahead and think about it. You can type in your answers if you think you know. All right, so we have a couple of I don't knows and a moving. That I do like that, but that is not it. Here you go, ready? It is a Roman numeral. And if you're not exactly sure what that means, this is a shortened way of saying roaming. Roaming means to move around, but Roman, with just taking the G off, sounds a lot like Roman numeral. We talked about Roman numerals before. So let's just revisit our Roman numerals. Remember where we used letters to represent numerals? This is what the Romans used many, many, many years ago. And as we talked about, you see this sometimes on Super Bowls. They name the Super Bowl using the Roman numerals. Sometimes you see it on movies. So let me show you an example. Oh, I found this cool thing online to help you remember. The phrase, it's kind of a funny phrase, medical Xavier, medical Xavier. What it does is help you remember the order. So whoops, let me use this one. 1,000 is M, 500 is D, 100 is C, 50 is L, 10 is X, 5 is V, and 1 is I. Medical Xavier. So it's kind of a strange term, but it will help you remember from 1,000 down to 1 what the main Roman numeral letters are. And here are some places you might see them. Star Wars. Which episodes is this poster representing in Roman numerals? Remember, the V is 5, the I is 1, and the X is 10. Can anybody write in what do these 3 episodes represent? So I see Henry says 7, 8, 9. People are excited about Star Wars. We have 7, 7, 8, 11. Anybody else? 7, 8, 9. Okay, so I'm so excited we got different answers, which means a great opportunity to learn. So this one would be 5, 1, 1. And because the larger number comes first, we're going to add these up. So 5 plus 1 is 7. So let me erase that out for you. Then this one is going to be 5 plus 1 plus 1 plus 1. Again, because the larger number comes first, we're going to add it up again, and that gives us 8. This one would be 1 and 10, but here's the trick. Because the larger number comes second, this x, we subtract the smaller number. So 10 minus 1 actually gives us 9. So those of you who wrote in 11 for ix totally understand why. That makes a ton of sense. But when the larger number comes second, you subtract the one that comes first. There you go. Another example, sometimes you see on clocks, Roman numerals. So let's see if you can tell me, what would this time be? Let's see, I'll use, that will be my short hand, and that will be my long hand. So what time is it on this clock? Let's see if anyone has any ideas. Go ahead and type it in. Anybody have, 3 o'clock, 3:13. Wow, that's very specific. 3, well, it would be 3 o'clock, 3 o'clock exactly, because this is 1, 2, 3. That would be our 12. So the short hand, the small hand is on the 3, the long hand is on the 12, so it's exactly 3 o'clock. Let's try another one. How about this? I'm gonna go with, whoops. I'm gonna try to get my colors right. All right, there you go. What would that be? Time for lunch. Yeah, if you haven't had lunch, you should probably try to grab something since it's already past 2 o'clock. Anybody have an idea what that would be? I see 3:30, 3:30. Anybody else? Anyone want to go with something different? I think we're good with 3:30. This would be 4, this would be 5, this would be 6. And there you have it. The shorthand is halfway between the 3 and the 4. The long hand is right on the 6, which we know is 30 minutes. So yes, it would be 3:30. Well done, guys. All right, let's go back to our fractions. I would like you to take some time and work on these. All you have to do is decide which is greater and which is less in each of these. So remember, you use this, whoops, that didn't work very well. Here is our greater than sign, here is our less than sign, and think about the benchmarks 0, 1/2, and 1. What that means is think about how is each fraction related to 0, 1/2, and 1. Is it close to 0, close to 1, close to 1/2, more than 1/2, less than 1/2? And draw a number line if it helps you. Go ahead and take a couple of minutes to work on these. I'm going to play a little bit more from our Mozart. Go ahead. Whoops, lost my music there for a second. Hold on 1 second. We'll get it right back in just a minute. All right, welcome back, everybody. I hope you were able to navigate these questions, but if not, that's okay. We are all learning together. I'm gonna start with this first one. We have 1/2 and we have 3/4. Well, we know 1/2 is right there in the middle. Whoops, 1/2. And we can decompose our halves into fourths. So that would be 1/4, 2/4, and 3/4. Again, that would be 0/4 and 4/4. That's why we've been doing all this decomposition and composition so that we can navigate these things pretty well. And so what we see is, well, here's a half, here's 3/4. So which is bigger, 1/2 or 3/4? It's clear that 3/4 is larger. And so we can go ahead and put our less than sign. 1/2 is less than 3/4. Remember, if you get confused about the less than and greater than, I don't want you to stress out about it. One thing I like to do is think about it like an alligator that's trying to eat the bigger number. Or it could be a dragon. Sometimes the dragon has fire coming out of his mouth to burn the larger number, whatever works for you. Okay, let's go to B. 1/2 and 7/8. Well, again, 1/2 right here. 7/8. Well, we can decompose our halves into eighths. How do we do that? Well, we're going to break this up into 8 pieces. 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. All right, so where is 1/2? Again, we know right in the middle. Where is 7/8? It's all the way over here. And that should make sense because 7/8 is almost 8/8, which is 1 whole. So it should be pretty close to 1, and it is. So again, 1/2 is less than 7/8. Okay, going to C, 2/3 and 2/5. 2/3 and 2/5. Well, let's start with thirds. If we want to do thirds, we have to break it up into 3 equal pieces. 0/3, 1/3, 2/3, and 3/3. And then if we want to do fifths, that's a little tricky, but we can do that. We would have to break it up into 5 equal pieces. So I'm going to draw another line up here just to make it a little bit easier to follow along. 1, 2 pieces, 3 pieces, 4 pieces, 5 pieces. So we would have 1/5 here, 2/5, 3/5, 4/5, and 5/5. So again, where are our numbers? Well, here's 2/3, and here's 2/5. And you can see that 2/3 is greater than 2/5. Another way to think about this one is to think about it in terms of where 1/2 is. 1/2 is right here. Now we know 2/5 has to be less than 1/2 because 2 isn't even halfway to 5. And we know 2/3 has to be more than 1/2 because 2 is more than halfway to 3. So that's another way to do it. Last, we have 9/10 and 3/5. I'm not going to draw it all out because our time is short, but 9/10, as you should think about now, is all the way over here, almost at 1. And 3/5 is about over here, not quite as close to 1. You can decompose your fifths into tenths, and you would have 6/10. So you know 6 is less than 9, and so in this last one, we have 9/10 is greater than 3/5. Okay, here is your homework for tonight. Go ahead, take a picture, take a screenshot. I would love for you to show me which is greater than, which is less than for these fractions. Remember to use your reference points, 0, 1, and 1/2. And if you need to, decompose your fractions so that you can help identify which is greater. Okay, and to leave you for today, today's riddle, again, take a screenshot, take a picture. It's like last night's, but this time we're doing multiplication, and I'm telling you what the numbers are. The numbers 1, 2, 3, 4, 5, and 6. You're gonna use each number once to fill in the slots below to make this multiplication problem true. All right, so you have 2 digits times a 1-digit number is going to give you a 3-digit number. And it's 1, 2, 3, 4, 5, and 6. And you only use each one time. All right, everybody, I hope you enjoyed our time together. And I look forward to seeing you again real soon. Let me bring my video back up. There I am. Have a great afternoon. Good luck with the riddle. If you get the answer, email me at jkamras, KAMRAS, @rvaschools.net. Bye, everybody.